Every time we fly, we're told to put our phone in airplane mode. And we do it, we don't even think about it twice. But the weird part is that no modern plane has ever crashed because of a phone. So why do we still have to do it? Look at a modern airplane. Up in the cockpit, pilots aren't surrounded by old analog dials anymore. They're flying with iPads, touchscreens, and fully digital systems. Back in the cabin, it's the same story. There's onboard Wi-Fi, USB ports, Bluetooth. Sometimes hundreds of devices are on at the same time. You can use your headphones, your laptop, even the Wi-Fi. And yet, the one device that still scares the airlines is your phone. Not the navigation system, not the computer, your phone. Something doesn't seem to add up. We've heard the excuses for years. Some people think it's to save you from a $1,000 roaming bill. But please, since when do airlines care about your wallet? Others argue that phones at altitude could overload cellular towers on the ground, which is actually a good guess. But modern towers handle thousands of connections every second. They're not affected by your phone. And then there's the most dramatic explanation of all, that leaving your phone on could somehow crash the plane. But let's be honest, if a single iPhone could actually bring down a $200 million aircraft, no one would politely ask you to switch it off. They wouldn't say, please. They would confiscate it at the gate. So, if it's not about roaming, and it's not because the plane is about to fall out of the sky, is it really necessary to turn the airplane mode on? Well, tell that to the pilots of this story. January 2020, somewhere over the United States. A commercial flight is cruising normally when suddenly the cockpit alarms start screaming. With not a single cloud in sight, the plane's computers report something impossible, Category 5 hurricane slamming into the nose of the aircraft. Out of nowhere, sensors are clocking wind speeds of over 250 kilometers per hour. Meanwhile, another plane just a few miles away reports nothing but a light breeze. The autopilot, completely baffled by these phantom measurements, begins to make erratic corrections, putting the aircraft at serious risk of an accident. The solution wasn't a system reset, nor an emergency landing, but to simply ask 200 passengers to turn off their electronic devices. And just like that, the hurricane vanished. It seems safe to assume that those electronic devices were somehow affecting the plane. So, how is this possible? Seriously, how can something so technologically advanced like a plane be affected by your iPhone? How can a small phone possibly affect a huge high-tech aircraft? Simple. Your phone is actually a radio, and a quite powerful one indeed. Every time you send a message, load a website, or receive a call, your phone is constantly emitting and listening for radio signals. Those signals are organized into generations that we call 3G, 4G, and 5G. Each generation is just a different way of using radio waves, different frequencies, different power levels, and different ways of talking to antennas on the ground. And under normal circumstances, this works perfectly. But planes are not normal circumstances. When you're on the ground, your phone connects to a single cell tower, maybe two. But at 35,000 feet, your phone can see dozens of towers at the same time. And because those towers were never designed to keep connected to phones moving at 900 kilometers per hour, your phone keeps screaming radio signals in hope to catch a connection, so it increases the power. It retries connections. It scans frequencies constantly. And that's where the problem begins. 3G and 4G were the quiet generations. They used frequencies far away from the plane's equipment. But then we invented 5G. And 5G is different. To understand why, imagine for a moment that the entire universe, everything that surrounds you, is filled with an infinite web of tiny, invisible springs. This web is what physicists call the electromagnetic field. When you turn on a light bulb, you're wiggling these springs very fast. When you use an X-ray, you're wiggling them violently. And when you use your phone, you're pulling and releasing these springs at a specific rhythm to send a signal. If everyone pulled on these springs at once, it would be chaos. So, we organize the springs like a crowded city. We call this the electromagnetic spectrum. Just like a real city, the spectrum is strictly zoned. Downtown, you have the radio district. The government sells specific blocks of the city to different companies. Verizon owns this block, the military owns that block, and aviation gets its own exclusive high-security neighborhood. For decades, the cell phone neighborhood was far away from the aviation neighborhood. But 5G changed the map. To get those insane speeds, 5G moved into a new luxury complex called the C-band. And here is the terrifying part. The C-band was built right next door to the frequencies used by a critical piece of airplane equipment, the radio altimeter. The altimeter is the plane's eyes. It bounces a signal off the ground to tell the pilot exactly how high they are. The altimeter operates at 4.2 gigahertz. The new 5G signals operate just below that, at 3.98 gigahertz. In the world of physics, that is an incredibly thin wall. When you're at 30,000 feet and your phone starts screaming to find a signal, it's like throwing a rave next to a library. Even if the walls are thick, the bass leaks through. That's what we call an interference. That leakage is exactly what happened in the hurricane story. The plane's altimeter was trying to listen for a precise response from the ground, but it was blinded by the loud party of 5G signals in the cabin. It interpreted that noise as actual data and gave the pilot the information that there was a hurricane when there was nothing but clear sky. Now, I know what you're thinking. If this is true, why aren't planes falling out of the sky every day? The truth is, aviation safety is built on something called the Swiss cheese model. Imagine 4 slices of Swiss cheese lined up next to each other. Each slice represents a layer of defense, keeping you alive. Slice 1 is the rules asking you to turn on airplane mode. Slice 2 is the engineering shielding on the plane's wires. Slice 3 is the technology software that filters out bad signals. Slice 4 is the pilot checking the instruments. Now imagine an accident is a laser beam trying to shoot through that stack. Because every slice has holes, human error, old wiring, software glitches, the laser can get through one slice easily. If you leave your phone on, the laser shoots right through slice 1. But usually it gets stopped by slice 2, the shielding. The laser hits the cheese and nothing happens. This is why planes don't crash every day. The holes rarely line up. But remember the hurricane story. That flight was a perfect alignment of holes. Hole 1, passengers left phones on. Hole 2, the plane's shielding was older and susceptible to the new 5G frequency. Hole 3, the autopilot software trusted the bad data. Suddenly, the laser shoots through all 3 slices. The only thing left standing was slice 4, the pilots. If those pilots had been tired or distracted or trusting their instruments blindly, that laser would have gone all the way through. This is why the airplane mode rule exists. A single phone probably won't crash a plane today because modern jets are hardened against this kind of noise. But aviation is a game of statistics. If you have 200 phones on board, all screaming at the wrong frequency during a critical low-visibility landing, you're eating through those layers of safety. The rule isn't there because a crash is guaranteed. The rule is there because when you're flying through the air at 900 kilometers per hour in a metal tube, probable safety is definitely not enough. You want absolute silence for the machines that keep you alive. So I have to ask, have you ever accidentally left your phone on during a flight and only noticed it after landing? Let me know in the comments. And if you're passionate about uncovering how the world around us actually works, consider subscribing. It helps more than you think, and it allows me to keep investigating these stories.